Okay, 6-8, day 2. Get ready to be challenged. Okay, still going to work with L'Hopital's rule, but this time we're going to be doing limits with the variable up in the exponent. So our first example, we would like to find the limit as x approaches 1 of x raised to the 1 over 1 minus x. Well, we're putting in 1 for the x. We'll just see what we got. We've got 1 raised to the 1 over 0 power. 1 over 0. How many times does something really small fit into something bigger? That's an infinity, so it's 1 to the infinity. This is indeterminate. The only problem is L'Hopital's rule only works when I have a fraction, and I don't have that. So I need to force a fraction to happen here. This one's a little more challenging than the one we had yesterday, in that I don't have a negative exponent. So I know if I bring this down, if I had a log, I could bring this down as a multiplier, and then I would have a fraction. But I can only hit both sides of an equation with a log. Well, I don't have an equation. All I've got is an expression, the limit expression. So what I'm going to do is say, make it an equation by saying I'm going to let L equal this limit. The limit as x approaches 1 of x raised to the 1 over 1 minus x. So L is going to be the answer to this problem when we're all done. L is this limit. Now what I can do, now that I've got an equation, I can hit it with a log on both sides and then bring this down as a multiplier. So I'll go with the natural log of L equals the limit as x approaches 1 of the natural log of x raised to the 1 over 1 minus x. So now I'm good with bringing this exponent down as a multiplier. So I haven't changed anything yet. So I got 1 over 1 minus x times the natural log of x. And I should have just wrote that in the top right here to save myself a step, but I didn't. I'll do it now. So I've got natural log of x over 1 minus x. And this is still the natural log of L. Okay, now when I plug 1 in, I get the natural log of 1 over 1 minus 1. Natural log of 1 is 0. 1 minus 1 is 0. There's my indeterminate form. So I am okay with just doing the derivative of the top and the bottom because that equals this whole limit here. So I don't have to do anything to this side. That's still going to stay natural log of L. This is still going to stay the limit as x approaches 1. Okay, derivative of natural log of x is 1 over x times 1. Derivative down here, that's a 0 minus 1. So now when I plug in, I've got 1 over 1 is 1. Divided by negative 1, I get negative 1. But that is not my limit. Remember, I've got natural log of the limit equals negative 1. So I've got the natural log of L equals negative 1. Remember what I said at the beginning, L is the limit. I got to figure out what this is for L. Well, all I've got to do is rewrite this in exponential form. So you're just going to use your rewrite property. I've got a log form here. I've got the natural log, which is log base e of something, I don't know what's under there, equals a number. I can rewrite it as the base raised to this power equals that. So remember, my base is e here. So it's e raised to the negative 1 power equals L. That was my limit. That's what I was looking for, was L. Okay, a little tricky. So let's go through what we did, and we'll repeat it another time. Start by writing an equation. You can pick any letter you want here, just starting with L because it's the first letter in limit. Hit it with a log on both sides to bring your exponent down to get a fraction, could have skipped this step here. Get a fraction. Do L'Hopital's rule over here. And then once you get your value, you have to still solve for L. So there's a few steps in them. They're a little more challenging. Let's try one more. Let's see, let's go with the limit as x approaches infinity of 4 minus x raised to the 1 over x minus 3. Okay, 4 subtract infinity looks like a negative infinity. 1 over infinity is a 0. Got negative infinity to the 0. That's indeterminate. What that tells me, I need a fraction yet. So we start out by writing, because I've got the x in the exponent here, and I got to bring it down, I need to introduce the logs. So I'm going to let L equal the limit as x approaches infinity of this. Now I've got an equation where I can hit it with a log on both sides and bring that down as a multiplier. So the natural log of L, remember L is my answer to my limit here at the end, equals the limit as x approaches infinity of the natural log of 4 minus x raised to the 1 over x minus 3. I'm going to bring this down and make a fraction. So I'll have 1 over x minus 3. So that puts the x minus 3 in the bottom. This natural log of 4 minus x is going to be in the numerator. So now when I put the infinity in, the natural log of negative infinity. Oh, I need absolute value bar. It's got to be infinity. Over infinity minus 3 is still infinity. Infinity over infinity anyway. So now we can do L'Hopital's rule. So I'll get 1 over 4 minus x times by the derivative here. It would be a negative 1. Let's put it in the top. Oh, I forgot my limit. All over derivative of this is going to be a 1. Now when I put my infinity in there, I've got negative 1 over 4 minus infinity all over 1. Negative 1 divided by negative infinity. Something really, really big going in. A 0. So that means the natural log of L equals 0. Solving for the L, just rewriting it in exponent form. That's e raised to the 0 power equals L. Anything to the 0 power is a 1. So the limit was 1. Okay, the assignment. Oh, I wrote it somewhere. That was day 1. Oh, number 22. Looks like I want to do another one. Good thing I saw that. Sure, shoot. Okay, let's do another one. Sorry about that. It has some trig functions in it. So example 3. This is number 22, so if I forget and assign it, oh yeah, because here's the, oh, I got to skip 22. Okay, we're all good. I would like the limit as x approaches 0 only from the right. So we're only approaching 0 from the right. Of sine x raised to the sine x. So here, plugging in the 0, I get sine 0 raised to the sine 0 Remember, sine of 0 is 0 to the 0, indeterminate, but I don't have a fraction. With that x up in the exponent, I've got to hit it with a log to bring it down, so that tells me I've got to write that equation like I just did in the last two. I can't just stick a log on the one expression here. I've got to have an equation and balance it out. Now I can hit both sides with the log and bring that down as a multiplier. So this can come out in front of the natural log as a multiplier. So I've got sine x times the natural log of sine x. Okay, well, I still have a problem here. I don't see a fraction. I've got just a numerator here, all over 1. So what I need to do is rewrite this to get a fraction so I can do L'Hopital's rule. Well, this can be rewritten. How do I rewrite sine? What is sine equal to? As a fraction? Think about it. Natural log of sine x is going to stay. But just sine x by itself can be rewritten as 1 over cosecant. So 1 over cosecant. That puts cosecant in the bottom of this fraction here. Okay. Plugging in the 0. The natural log of sine 0 over cosecant 0. Sine of 0 is 0. Natural log of 0 is, I believe, infinity. Let's see. Yeah, because I think you'll get an error. Clear. Natural log, I'll show you real quick. Natural log of 0. Yeah, you get an error. But if you look, because we didn't get rid of that. Clear. The natural log of x, the function. Natural log of x. We should have probably explored this function before we just kept using it. As I approach 0, what's happening is it actually never touches it. It just keeps going down and getting closer and closer and closer. So it's going down to negative infinity. Here's what's happening. So the natural log of 0 is technically negative infinity. And then cosecant of 0, if you look at that graph too, you're going to see you get infinity again. So we've got an infinity over an infinity, which is indeterminate. So we can do L'Hopital's rule. Don't change the left side. Derivative here would be 1 over sine x times by the derivative is cosine x. Cosecant's derivative is negative cosecant x cotangent x. Okay, if we do some simplifying first, I'll come over here. Cosine over sine is a cotangent. There I've got negative cosecant x cotangent x. I can see the cotangents will cancel each other out. I've got a 1 over a negative cosecant. That is negative sine.